Professor Belfrost's science class is back.
Hi everyone, welcome back. Professor Belfrost is here, and today we are again to discuss some topics from science subjects. And today I will discuss the topic of units and measurement, one of the chapter in physics. So are you ready? If you're ready, then let's set go. Okay, so as I have told you that today I will discuss about physics on the topics of units and measurement. So this topic is quite long and I'll divide it in 2 or 3 videos, and this is just the part 1 of this chapter. Okay, so let's see what we can learn today. So yeah, when we are talking about units and measurement, we need to know first um, about measurement. When we are about to measuring something, then we must have known what standard or what unit we want to use. So first, we need to choose what standard or what unit uh, we will have for the measurement. For example, uh, the measurement of 1 meter will be different from the measurement of 1 centimeter, though both of them has the number 1, but the units different. The first one is meter and the second one is centimeter, and of course it means different size of measurement. Okay, so size of the quantity to be measured then be found with the instrument having a scale mark in the unit. So complete measurement is called physical quantity. It made up of 2 parts, a number and a unit. For example, 10 meters, basically means 10 times meter. Yeah, so meter is just unit, 1 meter. So uh, you can imagine it like a variable. So 10 is the variable. We can substitute any number that we want that represent a multiplier of certain fixed quantity or fixed unit or fixed standard, which is in this case meter. So we have known how long is the 1 meter, and we just add 10 more. I mean, we just add 9 more the identical meter to create 10 meters. Okay. In physics, there are 3 basic quantities: length, mass, and time. And other units for other quantities are based on them. Yeah. But some book will include more than these 3 quantities, base quantity, which maybe you have candela, you have mole, you have ampere, you have Kelvin. Okay, but this is the most used one: length, mass, and time. Okay, so set of metric units used internationally is called System International the Units, or SI, a decimal system in which units are divided and multiplied by 10 to give smaller or larger units. Okay, so to give smaller or larger units, we usually use scientific or standard notation. For example, we can write 4, the number of 4, as 4 times 10 to the 0, or we can write 0.04 as 4 times 10 to the minus 2, or 4000 as 4 times 10 to the 3, where respectively 0, minus 2, and 3 in this example called the powers of 10. Okay, so I think it's quite clear. Yeah, let's move on. We can make a unit bigger or smaller by putting an extra symbol, a prefix. So if you don't want to say, oh, this is 4 times 10 to the power of 3, yeah, which is very complicated. For example, you want to say 4000 meter, you don't want to say the 1000, you don't want to say times 10 to the power of 3, you can just say 4 blah 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 meter. Yeah, this is the prefix, yeah, in front of the unit. Yeah. For example, for 4 times 10 to the power of 3, you can say 4 kilo, right? Okay, so for standard notation in calculator, you can see it as E. Capital E stands for exponent of 10, for example. In calculator, if you do some calculations and you obtain the result 3.56 E9 means 3.56 times 10 to the power of 9. Okay, it's easy, right? Okay, so here the powers of 10. We have some prefixes, and I think not all of them you will use every day. I mean, use often. The one that you will use often, I place it on the left side. Okay, like giga means 10 to the power of 9, mega 10 to the power of 6, kilo 10 to the power of 3, deci 10 to the power of minus 1, centi 10 to the power of minus 2, milli 10 to the power of minus 3, micro 10 to the power of minus 6, and nano 10 to the power of minus 9. But for example, you have also, yeah, iota, zeta, hexa, peta, tera. Or tera may be quite useful because maybe if you're electronic geeks, you want like, I want terabyte. Okay, so tera is also quite in use. 10 to the power of 12. So there are many others: hecto, deca, femto, atto, zepto, iotto. Yeah. Femto is quite used if you are talking about wavelength of uh, light, when you are talking about the radius of certain atom. So it's quite useful, femto, but you will not find it often in other usage. Okay, so you just need to memorize giga, mega, kilo, deci, centi, milli, micro, and nano. Okay, I think that is enough. Okay, so what's the main reason to write down in scientific notation? Yeah, so the main reason is that to tell which figures are important and to make writing more convenient. For example, yeah, you can just write uh 320,000. Yeah, but this is the result of measurement, and we don't know. We have no information if this is just what we are given, which zeros of these 4 zeros given are accurate. So if we express it as 3.2 times 10 to the power of 5, then only 3 and 2 are the figures that are important. Okay, but if we, for example, express it as 3.20 times 10 to the power of 5, then there are 3 significant figures. Actually, significant figures mean that this is the figures that we have a high confidence because we get it exactly from the measurement. But we are not like guessing it or rounding it up or rounding it down, because we actually see that that's the result they display when we measure something. Okay, so okay, you can see in the slide, if the number was known more accurately, we can just write it in 3 significant figures. For example, if you can have more accurate information, for example, you have 4 significant digits, just write it. You can have 3.200 times 10 to the power of 5. Yeah, it's up to you. Okay, it depends on how accurate a measurement being made. Okay, so significant figures given for measurement shows how accurate we think it is, and more figures should not be given than justified. Okay, so this is very important. We'll later learn about error of measurements. Then we need to take account of this. Okay, another example is, for example, 0.0385 has 3 significant figures. Yeah, 3 is the most significant one. Yeah, and 5 is the least significant figure, the least sure. Okay, if you are using calculator for calculation and the result is not the number of significant figures needed, yeah, because a calculator just show all of the decimal places, then you need to cut that number to uh, the number of significant figures that you are expected to deal with. For example, you want three significant figures, but your calculator gives you a number of maybe uh, 8 figures, then you need to cut them to only three significant figures. By what? By rounding it. Okay, so if the next figure to the right of the least significant figure is less than 5, then leave it as it is. But then if it is larger than 5 or equal to 5, then round it up. Okay, for example, here I have 3.41853. If you want to express it in three significant figures, then it must be 3.42. Easy, right? Also, we can open also in any calculation. Yeah, it's not only about physics, in mathematics, in chemistry, biology maybe. Okay, we also need to change units in which a physical quantity is expressed. So we use a method called chain link conversion. Okay, what's the meaning of chain link conversion? It just basically means that you need to multiply the original measurement by a conversion factor. What is a conversion factor? It's a ratio. I'm sorry, that's a ratio. A ratio of units that is equal to unity. It means that though these two uh, physical quantities has different number and have different units, but they are actually identical. They are equal to each other. For example, we have 1 minute and we have 60 seconds. They are both different in if we express it literally, physical quantity 1 and 6 are different, minute and second are different, but actually it represents the same quantity. So they are identical. So the conversion factor for this time interval is 1 minute over 60 seconds equal to 60 seconds over 1 minute equals 1. So for example, you are assigned to change 3.5 minutes to its proper seconds, how the number of seconds. So you can just 3.5 minutes times 1, yeah, which because you need to eliminate minute, it means that you need to choose the one that can eliminate it. You choose the conversion factor of 60 seconds over 1 minute, then you are to obtain 210 seconds, okay? And most of the time, maybe you need to do this chain link conversion more than once. Yeah. For example, you are about to change from kilometer per hour to mile per minute, for example, mile per minute. Then you need to change kilometer to mile and also hour to minute. You need to change it twice. So you need to multiply twice the conversion factor. I mean different conversion factor. Sometimes maybe the same conversion factor. For example, if you want to change from a volume, for example, you have meter cube, and you want a liter, which is just basically a liter is just a decimeter cube. So you need to apply the conversion factor of meter to decimeter thrice, 3 times. Okay, so just multiply, multiply, multiply again. That's how it works. Very easy. Actually, this is the first lesson with me, and this is just very basic things. Okay. So in SI units, units for measuring mass, time, and length are kilogram, second, meter. I say in SI units, you have many many type of units that you can use. But I say this is for SI that we have just discussed before. Okay, the international applied one. Okay, so other SI based units include ampere and Kelvin, as I have told you before. Okay, but we will focus just on mass, time, and length. Yeah, we will take time to discuss about it. Okay, so mass. When you are about to weigh something, that it means that you are to find the mass of something, right? Okay, so mostly you'll express it in kilogram. So actually, how much is kilogram? So a kilogram actually is just the mass of a piece of platinum iridium alloy at the office and measures in Paris. Okay, so you need to know this. Weight and mass are two different units. Yeah, weight may change if you are about to measure the same stuff in different places, different position. It may change, but mass will always be same. The fact that the confusion actually comes from that mass found on balance is by a process called weighing. But actually, uh, we are not finding the weight, we are finding the mass for that thing. Yeah. The second is length. So length, most of the time we will express it in meters, yeah, or the multipliers and meter. I mean kilometer, decameter, centimeter, the multiply of the meters. I mean the prefix plus meter. But the basic is meter, 1 meter. 1 meter was once defined as 1/10 millionth of distance between North Pole and equator. Then it changed again. It became the distance between two marks of fine lines engraved on a metal, a platinum iridium alloy bar kept at a bureau of weight on and measures in Paris. Then it changed again to be uh, 165076373. I'm sorry, the zero keep missing. I don't know the reason. There is something wrong with the font. Of a particular orange red light emitted by atoms of krypton 86. This is just one of many isotopes of krypton. Okay, and eventually, by definition, now that widely accepted is 1 meter is just the distance traveled by the light in vacuum in 1 over 299,792,458 of a second. Yeah, this is just a very tiny, very minuscule number. Okay, and then we move the time. So when we are saying time, 1 second, 2 second, 3 second. Yeah. So the basic is 1 second. So 1 second was one defined as 1 over 60 times 16 times 24 of a day. Yeah. And one day being the time it takes the Earth to rotate once. But the rotation of Earth actually is not very constant. It's not quite constant. It changes a little every day. And sometimes the Earth will wobble. It will affect the rotation speed. So we need to find the more proper definition. So scientists came to the definition that now 1 second is frequency. It's is defined as in terms of frequency of an oscillation occurs in the nucleus of cesium atom. Yeah, which is the time, the period taken by 919263177 oscillation of light of a specified wavelength emitted by cesium-133 atom. This is also one of isotopes, one of many cesium isotopes. Okay, you don't need to ask me. So please note that there is second mass standard. Yeah, I have told you before that the primary mass standard is kilogram, but if you are learning modern physics later, then we will not use kilogram that much because we need to deal with more accurate measurement, and we express the mass in new units called AMU or just U, atomic mass units. So how much is actually one atomic mass units? It equals to 1.6605386 times 10 to the minus 27 kilogram. Yeah, this is still a very uh, you know I hate this number. This just, yeah, You can see it. Okay, so I also have a picture for you, mass, length, and time. So there are many units for expressing mass. You can have pound, you can have gram, ounce, kilogram, ton. Yeah, what is CWT? Okay, the length you can have centimeter, yard, feet, mile, km, millimeter, meter. For time you can have second, hour, month, millisecond, year, day. Yeah, many more actually. We are not paying attention in this moment. Okay. So let's practice. This is just example for you. Okay. This is what the recap for today. Okay. So first, how many significant figures are for the length 35.6 millimeters, 3.56 millimeter, and 0.00356 centimeter? The answer is that they all have the same number of significant figures, which is 3, but respectively they have different decimal places. 35.6 millimeter, it has one decimal places, one decimal place. 3.56, two decimal places, and 0.00356 have five decimal places. But they all have three significant figures, which are 3, 5, and 6. Okay, I forget to tell you, my material is not very um, compact. I mean that I didn't show you previously. So you see that 0.00356, the zero here, though it is though it is shown, it is not. They are all not significant figures. So the only condition that zero becomes significant condition is when zero is between other numbers. For example, if I represent here, if I have a number 0.03056, then the zero between 3 and 5 will be significant figure. That's the one condition. And the second condition is that it's not in front of the other numbers. It is after the other numbers. For example, if I represent the third measurement as 0.003560 centimeters, then the last zero, yeah, after 6, it will be significant figures. So this number we have four significant figures. Okay, so I forget to tell you previously, I'm sorry, but there is how significant figures apply. Okay, second question, second problem, how many significant figures are there of 3000? What do you think? Yeah, I'm sorry, I forget to hide the answer first in that sense. So yeah, actually this problem is just a trap. Okay, without further description, it's hard to tell how many significant figures are there in 3000, in a number of 3000. We must assume that all of them are significant. So 3 significant, 000 also significant. So it has in total 4 significant figures. But actually this number can be described as any other forms. For example, I can just describe it as 3.0 times 10 to the power of 3. Just the same, right? Yeah. And now we have two significant figures. What's worse is that also we can change it to another form. For example, I will just say as 3.00 times 10 to the power of 3. Then it has three significant figures with it. So this is not clear. How many significant figures? I don't know. But yeah, maybe you'll never find this condition, because I just want to remind you that significant figure is very important in measurement. So don't play with it. Okay. The next is, okay, this question. I think this will be our last question for our last solved problem for today. I'll give you exercise after this. Okay, so let's read out the question. Okay, I'll read it for you. For about 10 years after the French Revolution, the French government attempted to base measures of time on multiples of 1 week consisted of 10 days, 1 day consisted of 10 hours, and 1 hour consisted of 100 minutes, and 1 minute consisted of 100 seconds. So, what are the ratios of A, the French decimal week, to the standard week, and B, the French decimal second to the standard second? So, the answer, okay, A, presuming that a French decimal day is just equivalent to a regular day, then the ratio, I don't know why I always type ratio in here. I think there's some bug in my keyboard. Okay, so the ratio of weeks is simply 10 over 7 or 1.43 if we express it in three significant figures. Okay, so for B, uh, the French decimal second to the standard second. Okay, so in a regular day, there are uh, 86 400 seconds, but in French system there will be 10 to the power of 5 seconds, as just it stated there. Okay. So the ratio is 10 to the power of 5 over 86,400, which is 1.16 if we describe it as for three significant figures. Okay, so that's my examples. Then I have exercise for you. Okay, this is, I want you to take screenshot. Okay, just spend as much time as you have to solve this problem. Okay, so I have read it for you. A dry is an old English measure for length defined as 1/10 of a line, where line is another Old English measure for length defined as 1/12 of an inch. Common measure for length in the publishing business is a point defined as 1/7 inch. Okay, what is an area of 0.50 dry square in point square? Okay. Second is spacing in some loop is generally done in units of points and picas. 12 points equal 1 pica and 6 picas equals 1 inch. If a figure was displaced in a page proofs by 0.80 centimeters, what was the misplacement in picas and points? Okay, you need to do this first because I don't provide the discussion, I just provide you the answer key. So the answer key is this. Yeah. Take a screenshot. Okay, then after doing this, check with the answer key that I provided. Okay, if you have any question, you have any differences in your question, in your answer to the solution that I provided, please feel free to chat in the comment box. Okay, I think so that's for today, and I'll give you a quote for today. Rainer Maria Rilke once said, "The only journey is the one within." Okay, yeah. So they are very, you have a long path to follow, but yeah, you are now with one of them, and you need to follow till the end for you to see the result. Yeah, you'll never know what you will become if you never put an effort, if you never try. Okay, so yeah, I want you to spend your time to improve yourself. Okay, like be better from yesterday. Yeah, that's just another inspiration. Okay, so thanks for watching. Here is what you have to do: subscribe to my channel, give a like, comment, and share this video to your friend. Okay, I will be back every Tuesday, Thursday, and Saturday, so keep watching and be thoughtful. See you in the next episode, and goodbye.